Great. Yeah.
Welcome, everyone, to the CAIS YouTube channel. I'm David Cormier, the Managing and Production Editor. We are sitting down today with Tony Savarimuthu to discuss his paper, Improving Information Systems Sustainability by Applying Machine Learning to Detect and Reduce Data Waste. So, Tony, if you would, please, for our viewers, just go ahead and summarize your paper, please.
Sure. Yeah. Thank you, David, for this opportunity to talk to you about our paper. So this paper focuses on the concept of data waste. So let me briefly introduce what data waste is. So organizations, with the advent of big data and the progress in information technologies, are collecting so much data, right? So in whatever shape or form, there is huge amounts of data that goes into organizations and businesses, and also as individuals, we collect so much of data, but not all of this data is going to be useful, right? So, for example, to give you a very practical example, we take so many pictures, and if you ask ourselves how many of these pictures are going to be useful, for example, if you take pictures about our family and kids, we might take the same pose 10 times. And you can easily see this is going to be a data waste because the pictures are going to be very similar. And we can apply this problem to the domain of text. There is huge amounts of duplicated data or useless data that we collect, and also in pictures, in images, in videos, and this quickly adds up. And the main problem is this new class of problem called as the data waste problem, where the data doesn't have this potential to add value, right? So it doesn't have that potential that you can extract something useful from that data. And that's the main premise of our work, where we look at detecting the data waste at its source. So as the data is being produced, if we can identify that it is data waste, then we can easily put in mechanisms to reduce that data waste so that it doesn't incur costs. For example, it incurs storage cost, it incurs processing cost, transmission cost, because data is duplicated and replicated in many different places. So this approach in the paper introduces the new class of problem called as a data waste problem, and addresses how we can use machine learning approaches to detect data waste at source. So that's the main contribution. As a part of that contribution, we've also quantified how much cost do we incur if we were to store data assets without pruning the data waste. So we look at it from a sustainability point of view, because to be sustainable, information systems should only capture data that is useful. So we looked at three characteristics or three pillars of sustainability. We look at if the useless data is captured, what are the economic costs, what are the social costs, and what are the environmental costs in terms of carbon dioxide emissions. And if we can quantify it, then we will know what kind of savings we can achieve through the mechanisms we are proposing in this work, which are machine learning mechanisms. So we have developed 13 different algorithms, or we applied 13 different algorithms to identify data waste. And if we can identify data waste successfully, then we can actually prevent it at source. So the main contribution is a set of mechanisms using machine learning models to detect data waste at source, so that we don't incur costs, and then we create a more sustainable world or sustainable ecosystem for organizations and businesses. So that's the main high-level contribution of the paper.
Excellent. Thank you, Tony. So your paper is shortlisted for the 2023 Paul Gray Award for most thought-provoking paper. So looking back at your research and thinking, what do you think now is the most thought-provoking aspect of your paper?
Yes. So thank you for shortlisting our paper. So the thought-provoking aspect is to treat this problem of data waste as a new class of problem, right? So far, because organizations have the power to capture so much data, if anyone thinks, oh, let's actually put everything in, let's collect whatever we can. So there is a voracious appetite for collecting as much information as possible without thinking about the ramifications of the data capture, right? So I think we have introduced a new class of problem, And for this new class of problem, considering just the textual data, we have applied both machine learning and deep learning mechanisms to identify what the data waste is. And on top of that, we have produced a calculator, a sustainability calculator, which can actually help researchers to think about what would be the cost. How can we quantify the cost of data waste in such a way that we will know how much carbon dioxide are we producing more because of this data waste? How much time are we wasting for users, for example, by giving them the waste data? So looking at the 3 dimensions. So the most thought-provoking aspect would be to treat this as a new class of problem, and for one kind of data, we show how we can operationalize to identify data waste and then quantify the cost. And our mechanisms can then be helpful to actually reduce or prevent data waste in the future. So that's the contribution or the thought-provoking aspect.
So looking back, thinking back, reflecting on your research, would you have done anything different? Is there anything you want to do now related to this subject?
Right. So now that there are these large language models, so what at that point in time, we were only looking at traditional machine learning algorithms such as decision trees and deep learning algorithms. If I were to do it now, I would also compare our results against those existing works. Having said that, our deep learning mechanisms were already achieving really high accuracy, right? It's about 99% in the top class. But with the large language models, it is even possible to push that threshold higher. So I don't think it would change the result dramatically, but still it will be good to see if we can actually push the bar. And our approach already shows that there are differences in different data sets, right? For example, in the context of app reviews, when a review about an app is being written, there is more data waste. So some domains seem to produce more data waste than others. For example, restaurant reviews, there was only 2% data waste. So that was quite interesting for us. And if you had to do, I would apply this new technique to what we have done, so that we could demonstrate better performance. And also another approach would be to choose look at other domains. For example, the reviews, we only looked at 2 different review domains. We could have done it for example, books or movie reviews and so on, product reviews. It's a whole range of subjects that we could have treated. So if I were to do again, I would probably try to scale it up a little bit more so that it's much more broader.
So excellent. Thank you, Tony. Now, what are you working on now? Is there any research that you're currently working on, related or unrelated, that you would like to share with our viewers?
Yes. So what with the team of researchers working on the paper, some of the ideas that we have is to actually look at large language models. So I've been working with large language models to identify social concepts. For example, does it understand the concept of social norms and so on? But related to this particular paper, nowadays the large language models also have the ability to take into account photographs. We could actually analyze data waste in photographs and so on, and some of the models can handle even videos, right? So we could take our work and then we can easily extend it to other forms, and those forms may have actually a significant impact, because when compared to textual data, you know that the pictures and videos, they are much more bulky, right? So you need more storage, more processing, more transmission time, and so on. So the impact is going to be quite significant in terms of identifying data waste and even preventing it. So if you can actually prevent even, say, 10% of the data waste going in, it's going to help sustainability in the longer term. And hence, information systems are not only uses of power, because they're power hungry, and storage hungry, we could actually make them more efficient. So it's about making information systems more efficient and also contributing to the sustainability goals, long-term sustainability goals of the world. So that's what we have in mind for the future.
Yes, it's a noble effort, Tony.
Oh, thank you. Thank you.
Absolutely, absolutely is. Thank you for sitting down with us today. Thank you for sharing your research. It's been wonderful.
Okay, fantastic. Yeah. Thank you, David, for this opportunity.